about chapter 5, page 100. Okay. So we discussed this on the last class, but we will now do this in detail. So this is chapter 5, page 100. This is 5.4. So what was the case? In this case you had two blocks, right? One block was on a table and the other block was hanging by a pulley. So you had a diagram like this. This is one block, this is a pulley, and you have a string attached going over the pulley, and there is a block over here. This was the problem statement, right? So the bigger block is called the sliding block S for sliding block. The smaller block was called the hanging block H. Also it is given that the mass M of this block is equal to 3.3 kg, and the mass small m for this block is equal to 2.1 kg. Right. Now what is the problem? The problem is that you have to find the acceleration of the block. Okay. So first you read the problem statement, then you break it down into parts as you understand, and especially like I told you before, many times it is very helpful to draw a diagram to understand the problem. Okay. So these are like vector diagrams or free body diagrams, whatever, like schematics. Okay. So in this case we have written what is given. And of course, you know that when there is a string and you have a mass attached to a spring, it will experience a certain force that we call tension. So there will be a tension, right? A tension force which we normally represent by the symbol called capital T. So we studied this last time, right? We also know that when a body is hanging in the vertical direction, it experiences a force due to gravity. This is known as the gravitational force. So these are the forces that are acting in this case, right? So we have the gravitational. So this problem is very interesting in the sense that we are using all the concepts that we have studied, right? Okay. Now what do we have drawn the diagram, we have written down the quantities that have been given, and we have explained the problem, right? Now the next step is to identify what has been asked, what are you required to do. So in that case, number A, you have to find the acceleration, right? A for block S, the acceleration of this block, okay? And then you have B, the acceleration of block H. So acceleration for block X, S acceleration for block H, and we have to find the tension in the cord. Number C, the tension in the cord. So this is the problem. Okay. How are we going to explain this problem? So the next step will be that let us draw the forces acting on this. We know that in this case, when something is sitting on a surface, it experiences a gravitational force which is F, G and S. S for the block, okay? We are identifying this as S. And the force that is acting upwards is Fn. This is the normal force. So we are using another kind of force which is the normal force, and then it is being pulled in the right direction, and this force is called the tension T, capital T. Okay, now this is for block S. For block H, again we can draw the forces. The block H is experiencing a tension force which is upwards. It's experiencing a gravitational force Fg which is downwards, and it is not experiencing any force in the horizontal direction. There is no force in the horizontal direction for block H. Is that clear? Okay. Now the next step. The next step we will draw the free body diagram, or what you can call the vector diagram. So, in order to draw the vector diagram, we will just draw the vectors and we will represent the masses with a point to simplify the problem. So, in this case we can, in order to understand this, we can draw this according to the axis, like we know in 2D we have the x axis along the horizontal direction and we have the y axis along the vertical direction. So, we have now this body which had a mass m, we are representing it by a point, okay, and we are drawing the forces Fn which is upwards along the y axis. This is Fn, this vector, this is Fn, okay, and then similarly towards the lower side of y, the y axis upwards is positive, downwards is negative. So, in the negative direction we have a force acting on this body which is, we just said, Fgs, and then on the right side we have a tension which is T. Tension is a kind of a force, okay. So, because of the string and all that, whenever you have, so you have forces in the vertical direction and you have force in the horizontal direction. Whenever you have a force, the second law of Newton tells us that there will be an
force acting on the body.
Whenever a force is acting on a body, it will produce a acceleration. Very good. So, this is a main concept. You identify the formulas, the laws that will be applicable to this scenario, right. So, the main formula that we will be using will be F is equal to ma, because we have forces, we have mass, and we have to find acceleration. So, this is the formula we will be using, but we have to use it with understanding, because it is not going to be simple F is equal to ma. We first have to draw all the vectors and then understand where we have to apply it how. Okay. So, just break it down, relax, and break it into parts and then solve it part by part and you will understand it. Okay. So, this is for the body S. And for the second body, this one, the small one, okay, we draw another diagram and again we draw it in the same way along the x axis and along the y axis, in order to understand which forces are along the vertical axis and which forces are along the horizontal axis. So, along the vertical axis we know that we have the tension T, okay. So, we can draw the tension here. T is upwards and it is being balanced by the gravitational force, which in this case we are calling it H. And remember, the T is a vector, so we can also denote it by the vector sign. Okay. The mass of this body is m. This is for the body H. This is H. This is S. Okay. The mass here is small m. And this the acceleration in this case will be towards the right. The acceleration in this case will be upwards or downwards depending upon which force is greater. Okay. So, in this case, if for example this force is greater, then the acceleration will be downwards. We will now try to put in the values and understand which of these forces is greater. Okay. So, now we understand the problem, we have made the diagram, we have written the values that are given, and we have also identified the tasks that we have to do, what has been required for us to do. Now, let us go back again and let us try to, we have also identified the equation that we will be using, which is the main equation is Newton's second law. Now, but again we cannot use it right now, we have to first understand which force, which mass, which acceleration goes where. Okay. So, in order to identify that, we are going to talk about F net. Okay. Net means total, because there is not one force, there are more than one forces. So, we have to identify the total impact. Okay. Now, if we are talking about the block S, for the block S, this becomes capital M, right. For the block S, the mass is capital m, okay. And then like if again you want to remember that this is a vector and this is a vector, the mass is not a vector, okay. Now this is the formula, but then we know that we have components in x, y and z direction like we studied before. So we can also write it in component form. So f net x is equal to m a x, then we can write f net y is equal to m a y, and then f net z is equal to m a z. Now